Hello and welcome to this Chemistry World webinar. I'm Ben Valsler, Chemistry World's digital editor, and I'll be your guide through the webinar platform that we're using today to help you make the most of the next hour. Thank you very much for joining us. Now, with all that covered, I can introduce our mouth-watering topic for today. We are taking a journey into the chemistry behind some of the world's most iconic festive breads. Focusing mainly on Europe, we'll be looking at the different sorts of breads that people have for Easter, and we'll be deep diving into the chemistry of how they are baked. We have sent Chemistry World's Ada McVean to Leicester to join today's guest speaker, and she can be our eyes, ears, and importantly, taste buds in the chemistry kitchen. Joining Ada today is Josh Smalley, who's a postdoctoral research associate and science communicator in the School of Chemistry at the University of Leicester. He was also a finalist in the 2023 Great British Bake Off, where he captivated audience with his skillful techniques and mastery of flavours. Today, he's going to be taking you through the chemistry of those baking events. You get to find out a lot more of the science of what's actually going on when you bake delicious things like hot cross buns and other Easter breads from across Europe. So let's go now to the chemistry kitchen. We should be able to switch the cameras on over there and see everybody. There we go. That's a very good sign. Ada, everybody left back here in the Chemistry World offices is, of course, very jealous that you've had this opportunity, but thank you for travelling to Leicester for us. Josh, thank you for joining us. Ada, I will hand over to you now.
Thank you, Ben, and a massive, massive thank you to Josh for inviting me into the chemistry kitchen. I desperately wish you guys could smell how it smells in here and eventually, hopefully, taste, although I'm very excited for that.
All recipes will be made available so everybody can have a go themselves.
Perfect. So we'd love if you do try out any of the recipes, if you send us your attempts, we'd love to see that. Reach out to us on social media. We're at Chemistry World on almost every platform. And so, Josh, what do you have for us today?
Hello everybody and welcome to today's webinar. This is the second one we've done now with Chemistry World. We did one on chocolate last year. This year we're similar sort of time. We're here at Easter as we build up to Easter, and we're going to be doing chemistry of Easter breads, in particularly focusing on hot cross buns, which is going to be the focus of the demo, and I've got a couple of other ones of other European Easter breads that we're going to delve into, and I'll show you those towards the end of the webinar. So what we're going to do, it's going to be a little bit of back and forth. There'll be a few demos and I'll go to a few slides which are going to go through some of the chemistry and some of the science in depth on what's actually going on in our mix as we put this hot cross bun together. So to start off with, I've got a few slides just to go through a little bit of an introduction of who I am and the reason for going into this space of doing all of this wonderful science of the baking. So what I've got my clicker here. So yes, today's talk, rising to the occasion, the chemistry of Easter breads, and a little bit of an intro. So for those that haven't watched the Great British Bake Off in 2023, I was in it, and all the way through to the final. There's a final three, and that is me in the final on the right-hand side there, alongside Matty and Dan, who are the other finalists with me, and you can see the judges and the presenters alongside. We've got Noel Fielding, Dame Prue Leith, Alison Hammond, and Paul Hollywood. So that was 2023, and that's where my sort of little rise to fame. People have seen me as a baker, but by day to day, I am a chemist. I work at the University of Leicester. I'm a postdoctoral researcher in chemical biology. I'd actually just finished my PhD about 6 or 7 months before the Bake Off sort of started the filming process. So I was doing my postdoc whilst the filming was taking place, and that is me on the left-hand side in the chemical biology lab. So I experiment by day and by night. I'm experimenting in the lab in the day. I experiment at home in my kitchen in the evening. So that's the little introduction. And now I just thought I'd give you a little bit of an intro as to what really got me into, well, why I do the chemistry of the baking, but what first got me inspired to want to do chemistry, really, because it actually started from baking and then went into the chemistry. So that's what I've got on these slides here. So I can remember from a very, very young age, always loving to bake. It's always been it's something passed down. My mum and my nan were avid bakers. They helped sort of like inspire me to get into the kitchen and do that. And I think I just loved that sort of creating a new product, mixing ingredients together, and we got something at the end. And I think then going into doing science at school, I realised very quickly that chemistry was the science for me, because it was very much like my baking at home. It was following a recipe or procedure and putting things together. And so what I've put here is this first This is a reaction. I remember us doing this. I think it probably would have been GCSE or A-level, making aspirin, salicylic acid. We've got our acetic anhydride, a little bit of acid catalyst with sulfuric acid. We'd have had this probably in a flask, in a water bath on a tripod with a Bunsen burner underneath, and we'd have made our aspirin. And again, it's always just about, I remember vividly back then thinking this was just about like following a recipe at home and making a product or a bake at the end. And so that's making aspirin, but how my head works when I saw chemical reactions back then, but even now, it is just putting ingredients together and you're getting this product at the end. So like making bread, we've got our flour, water, salt, oil, bit of yeast and heat, and we get our bread at the end, and the same for making our cakes. And actually, the more and more I've gone into this, and especially with the bake-off, I've realised quite how many overlaps there are between baking and chemistry. So I've put a few of those here on this slide, and it's like I've already alluded to, you've got that, you're following a procedure in both cases. You have got this whereby you're combining combining ingredients together to get a product at the end. The order of addition is really, really key, especially with certain bakes, whereby you've got to make sure, like chocolate tempering, where you've got to make sure you're bringing your temperatures down to very, very specific temperatures before taking them back up again. Things like making choux pastry, again, they require very specific orders of addition to get a really good result. And it's the same in the chemistry lab as well. We have to often pre-cool our mixtures before we add certain bits or the next reagent. And then we have heating. We're heating in the kitchen, we're heating in the lab, and we get a product at the end. And the one, especially when it comes to bake-off, I would say scale up is another one where there's a lot of overlap, because on the bake-off you've got to make things en masse, on big scale. I've never gone through as many eggs as I did do in 2023. It was just, every bake you were doing, you were cracking up 20 eggs to make these things on a large scale. And it was really, and actually then baking these big bakes, it's very much like scaling up in a chemistry lab. There's so many more considerations to build in, because everything takes longer to put together, to weigh out, to bake. It takes longer. You might have to do it in 2 or 3 goes. And again, it's very akin to how it is in the lab. And then the other thing is washing up. Washing up is also, when we get on bigger scale, washing up is a problem in the kitchen, it's a problem in the lab. You never want to do it. It always gets left to the end. And then the final thing is, it's not always a success. Not always does baking work first time. Not always does chemistry work first time. So I think collectively there's a lot of overlaps between baking and chemistry. I think that's why I love them both so much, and both of them almost equally inspire me to want to take the other one to another level. So that's that. Now we're going to go into what we've got for today's focus of the webinar, and what we're going to be doing is we're going to be making hot cross buns. Now this is the recipe on the slide, and then we're going to go through it step by step. Like I said, what we're going to do is we're going to do a few slides of chemistry, and then we'll come back and I'll do a little bit of a demonstration, and then we'll go back to the slides again. And like I said, this recipe will be available for everybody to have a go at afterwards, so no excuses. You'll have seen the chemistry of it, you'll have given the recipe, you've been given the baking demo, so you can make it yourself in time for Easter. So you can see there we've got the ingredients for the dough. The filling has got sultanas in, which I've actually pre-soaked in a cinnamon tea, which is a really nice addition. I did it on the bake-off as well, actually, and it really helps to plump up those sultanas, so we're going to go showcase that, and then we're going to go through all the other bits as well. So if we come back to me for a moment, so we can actually see me, not just the slides. Here we are. Here are the hot cross buns that we're going to be making. I think we've got another camera angle up here on our camera 3, which will just show you up close, hopefully, top down. That is what we're going to be making. And I've got lovely apricot glaze, which gives them a lovely shine. Now, if I take those away, you can see here I've got all of my, still on camera 3, you can see I've got all of my ingredients here, what we've got. So we've got our flour, we've got our sultanas that have been soaked, we've got our yeast, we've got some spices, the butter, the sugar, the egg, some milk, and the oranges are just here that we're going to put into the mix as well. So before I'm going to add all of those, what I'm going to do, I'm going to go back to the slide, just give a little bit of an intro on what the ingredients are, what the purpose is actually for the bake. So if I go on to the next slide now, I'm just going to go through what these ingredients are. And if we actually if we can have the small screen of camera 3 in the bottom corner, I'll show them all as we come up. So we're starting off with our flour, what's in our flour. And I think it's really good to go through these individual ingredients, because in its simplest form, we just see bread as flour, salt, bit of water, a bit of yeast, and that's it, we've got a bread. But actually, when you dive into what's in the ingredients, there's a lot going on in our mixing bowl. So we're starting off with our flour, and I've divided it into the 3 main things that we've got in there, that especially with relevance to helping to make the bake. So we're starting off with our starch, these complex carbohydrates, these polysaccharides. We have got These are long chains of alpha glucose, all linked together, because we can have the two main types. We've got amylose, we've got amylopectin. Amylose is around about 20%, amylopectin about 80%. And these are just these long linear chain for amylose. And then in the amylopectin, we've got, again, a linear chain, but it's branched now. So it's got these, we have the alpha 1,4 glycosidic bonds going through, and then the branching is a 1,6 glycosidic bond on these amylopectin. And that branching makes that it's quite insoluble, which is why, again, when we add water to our flour, it doesn't really mix in, it doesn't dissolve in water at all. It's not very soluble at all. So that's the starch aspect. We then go over to the main star of the show, for those that can have gluten, is the gluten proteins, which is helping to generate our wonderful gluten network, and which is what we need to be able to get that wonderful risen dough. In there, we've got gluten proteins. The main two here, we've got our glutenin and gliadin. These have got two different forms. So glutenin is a very sort of fibrous. It's lots of proteins together, polymer, and we've got long strands. Then we've got the gliadin, which is a bit more globular, and they're monomer units. So and then collectively they all come together. And I would usually describe them a little bit like spaghetti and meatballs, actually. So you can see you've got the long strands, you've got the more globular ones. They all come together, and that's going to make our gluten network. We're going to go through that in a few slides' time. And then we've also got a variety of enzymes as well. And we're going to touch upon the enzymes later on. So we've got the amylases, the hydrolases, which are going to help to chop up our polysaccharides, our carbohydrates. And we've also got at the bottom, you can't quite see it there, and that is ascorbate oxidase, which again is another enzyme present in our flour. Alongside other enzymes as well, and I'm going to talk about that as well and what that does within the bake as well. So that's the first bit. Then on the next slide now we've got, so the flour is the main part. We're then going to go into the other main points. We've got our salt, our water, and our yeast. So salt, we know that is going to be there for, first of all, we know it's there. We have it there for taste, for flavour. We're using salt all the time. And we know it's one of our five key taste senses, so we know that's going to add some flavour, but it also has a lot of other roles as well. So it's there to control fermentation. So without the salt in there, your yeast can actually it can almost ferment too quickly. It can go a little bit overboard. And as a result, it can actually have a negative effect on your gluten network that you're forming. It can actually not really have the strength. It can collapse a little bit. So you want to have it to be able to control the activity of that yeast. But it is actually also, the salt's also going to help to strengthen the gluten structure as well. With it being charged, we've got our sodium, our chloride ions that's charged, and it helps with the proteins that are in our gluten proteins, so our amino acid side chains that we've got in our, of the amino acids in our gluten proteins. The charges of our sodium, our chloride, are going to just help to reduce some of the electrostatic repulsion, help to encourage more hydrogen bonding, and help to really get a lovely gluten network. And we're going to go through that in a few slides' time. And then alongside the salt, we've also got the water. So obviously water, the main bit there, it's really helping to bring everything together, helping with dissolving some of our ingredients, distributing them out, helping with the consistency of the dough. But it also is going to help for hydration as well. It's going to hydrate and activate these gluten proteins and the yeast and the starch. It's going to help to gelatinize the starch so we can then make the polysaccharides in there accessible now to be chopped up by the different hydrolases. So that's the water aspect. We're actually going to be using milk and egg as the liquid component today, but they're all main component is water, which is what we've got here to help bind it all together. And then we've obviously got the yeast as well. So yeast, we know it's going to consume the sugar, the glucose by fermentation, create our carbon dioxide, create our ethanol to help give a lovely rise to our bread, but it also is helping to develop lots of flavour compounds as well. So that's the main few ingredients. If we now come back to me, we'll now start to mix them all together. So let's mix these into a bowl. So we've actually got this wonderful, brand new, it's actually state-of-the-art uni. They make all the pizza ovens. They've got a brand new mixer out. This is the Halo Pro spiral mixer. So we're going to be using this to help make our dough. So I shall bring this into shot, and we're going to add the ingredients in. So we've got 500 grams of bread flour to start off with. Move it out of the way. And then we're going to add in our yeast. So we want, I think I've said about 12 grams of yeast. So that's going to be about 3 teaspoons. So we'll just put that in. Just put the yeast in. To the side. There we go. Have you made hot cross buns?
I've never made them myself, but I do enjoy eating them very much.
I absolutely just love them. I would have them all year round if I could, but they're only really in shops just for this specific period. So we've got our yeast in there. Other side of the bowl, we're going to add a bit of salt now. So you want to keep them separate for now, otherwise it might kill the yeast. So we'll just get that. So I've got about a nice big teaspoon of salt.
Is it more important to weigh certain ingredients, and you can, use more teaspoon volume measurements for certain things?
I mean, you can get away with all different types of amounts of yeast. It's going to affect how quickly it's going to rise as well. So if you want to get a really lovely flavoured bread, people can use really small amount. You could put like just a gram or 2 grams in, do an overnight proof, and it'll just really slowly ferment, and it can help develop a greater flavour. Tends to be around about, for a half a kilo of flour, it to be around about 10 grams of yeast, 7 to 10 grams. So that's fine. So we've got our salt there, and as this is an enriched dough, we've got the sweet, the fat, the lovely parts that make these doughs really moreish. So we've got some sugar in here. And this is 50 grams, and then we've got some butter as well. Would you just pop that in the microwave for 20 seconds, just over there?
Absolutely.
Lovely, thank you. And we've got a bit of butter, and then we're going to add in our egg and our other liquid components. So I'll make room here. Let's crack the egg in. So put the egg down here, like so. Move that out of the way. And then I think that's really it. So just going to add in our butter, and we're going to add it in our milk, and then I'm going to get that dough coming together. I like to add my fruit aspect a little bit later on, because sometimes it can compromise that initial sort of gluten formation. That's wonderful, thank you. So we should put the butter into here as well. Perfect.
Now, if you're a lazy baker, could you just melt the butter entirely, or will that change?
You could melt it. You want it to be room temperature soft butter. Mine's just come out of the fridge, which is just why we just give it a little bit of a warm just to help get it going. Otherwise, you might get little clumps of butter in the mixture. So that's all of those in here. So we've got our flour, our salt, our sugar, our yeast, our egg, our butter, and we've got 250 ml here of milk. So we're going to put that in as well. And now we're going to get that mixing in here, hopefully. Put that into there, and then turn this on, which makes a nice noise. There we go. And then we'll get that stirring. And the bowl moves as well as the actual hook. So leave that on there to stir. If it's too noisy, let us know and we can turn it off. But that's bringing the first two bits together. And then we're going to then begin to add our fruit and our orange zest and our spices is going to be the next bit. Before we do that, I thought what we'll do is I just have a few slides just to go through gluten formation, which is what's happening in that bowl right now as it's all beginning to come together. So we'll go back to the slides now. What we've got is we're combining our wet and our dry ingredients. So I might just turn that off a moment, so we can hear all of that. I've got another dough prepped anyway, so we don't really need to see that right at the moment. So we've got our wet and our dry ingredients. We have got, we're going back now looking at our gluten proteins that we've already talked about, the gliadin and the glutenin. These are our flour proteins. What we're doing here is we've added in our liquid component, our milk, but it has got water in there. That's going to help to hydrate these proteins now. And once they're now hydrated, they can then begin to be moved together, mechanical action, as we're actually beginning to knead into the bowl. And as we do that, we're going to begin to form this gluten network. And you can see here, when I described it as spaghetti and meatballs, that's a little bit what it looks like on the top right now. So you can see we've got the long fibrous strands of glutenin. We've got our gliadin all mixed together now, and we're forming that gluten network. So that's what's going on when we see then the texture. That's helping to give us that wonderful texture of our bread. Now, that's what we've got for bread. But what I thought I'd also talk about actually is if we're making a biscuit, how would we approach it, and how does the method and the procedure we follow differ to this? Because we don't actually add the water first when we make a biscuit. And that makes a nice link to add because we're making an enriched dough. So actually we have got lots of fats to consider. So if we were to make biscuits, what we want to minimise the gluten network. We don't want gluten. We want to have a nice, short, crumbly biscuit. You don't want to have that so that it's, you don't want it to have a bendy or stretchy biscuit. Mm-hmm. So we want it to be nice and crumbly. So what we do when we do our biscuit is we rub the fat in first. When we rub that fat in first, you can see on the slides now, we're coating those flour proteins now in this layer of fat on the outside. As a result, when we then do add a little bit of the liquid element, whether it's a bit of egg or milk, we're actually then, it's harder for those gluten proteins to actually now hydrate and take in that water because we've got that layer of fat to interfere with it. As a result, we can then, so we rub our flour together with our butter. So it's like if you're making a scone, you'd mix them in first, and then you just add the water at the end, just to bind it together to hold it, because we don't want it to be all glutinous. And actually what that's kind of, and as a result of that, when we do that, you'll end up with less gluten formed, as you can see on the slide, and we end up with a lovely, nice, crumbly biscuit. But now what we've got here is we're making an enriched dough, and with an enriched dough, we're adding in lots of fats. So we've got our we've got the butter in there, we've got our egg, we've got our milk, so we're adding in fats. So actually when you do make an enriched dough, you often need to knead it for a bit longer, which is why most brioche recipes, you'll see they often will go back to a stand mixer as opposed to kneading by hand, because you tend to put them in there for 5-10 minutes to really get them going, get that gluten formed before we then leave it to prove. So it really does need that little bit to get going. So let's mix this back on, because we need to get this to come together. So I'm gonna, hopefully this isn't too noisy, and we'll get that all mixing together. And then once we do that, I'll just prep the next few bits that we need to do. So we'll leave that mixing on there. What I've got here is we've got some sultanas. So if you can look on the top down, you'll be able to see we've got the sultanas, and they've been soaked in a cinnamon tea. So I use these Pucker cinnamon tea bags. They work really, really nicely. They're lovely because they're a blend of different cinnamons. So you've got Sri Lankan cinnamon and Vietnamese cinnamon. There's different ones that each add their own subtle sort of note.
So it'll really add some depth.
Really add some depth to it, yes. So I soaked them in that overnight. So we've got 3 tea bags in here, which I can now take out. And then we can just now take off that remaining water that we've got. So let's just do that. We'll turn that off again now, just so we can hear what we're doing. So that dough's come together nicely. So we've got that there. We're now going to sieve off the liquid that we've got here. So we can just put that into the bowl here. Take that off. And this, you can see these are really nicely plumped up now, and they work really well for any sort of like fruit bread or spice buns like this, because what you've got is it mixes, so they're really nice and juicy, and they don't sort of like set rock hard. Sometimes what you can have when you've got your if you just use straight dried fruit, they can be a bit like bullets on the outside. They're really, really rock hard. These stay really nice and plump and juicy.
Now, have you worked out any use for the liquid that you strain off it?
So the liquid, actually, that's a really good point. So I mentioned that I'm going to use apricot jam for the glaze. What you can do is you can take that liquid, you can add a little bit more sugar to it. So I've actually got, there's 2 teaspoons of sugar in there as well. You can add a little bit more to it, and you can put it into a saucepan. You can reduce it down, and you've got like a cinnamon, sticky glaze. That works really nicely over them as well. So if you don't go for the apricot jam, you can use that as the glaze. Okay. So don't throw it away, because it is. You'll be able to see. You can smell that it's got a wonderful smell to it.
Can I drink it?
You could probably, it'd be very sweet, but you could probably make it into some sort of like, you could do it as like a pump syrup almost to put into a coffee.
For a coffee or a cocktail? Really well.
So yes, that's what we've got there. These are now going to be mixed into that dough, and we're also going to zest some oranges as well. And then we're going to add some spices as well. So maybe we'll actually put all of them in now, and then I'm going to go back to some more slides that we've got. So let's list this out, and then just so we can do this. So obviously we would normally have mixed this together a little bit more, and we really would develop that gluten network. It'd be really nice and stretchy. But for the purpose of the webinar, we're just going to put all these in now, and bring this together, and then we will we'll switch to one that I've already made earlier. So we've got our fruit we can mix into here now. So we'll mix the fruit in. That's been nicely dried off. We're also going to add in our spices. So we're going to add in some mixed spice. So I'll put a teaspoon of mixed spice in, and we're going to add in some cinnamon.
I've actually never heard of mixed spice before. I'm wondering if it has a different name back in Canada.
It's a nice blend. It's got cinnamon in as well. It's got a bit of orange in, I think, because it's got clove in as well. It doesn't say, does it? So yeah, cinnamon, coriander, nutmeg, clove. So it's just a really nice general mix. So we've got that in there, and we're going to put in the zest of 2 oranges. So we'll quickly zest those in here as well. And whilst I zest these into here, maybe we'll go back to the slides now, and we can go through some of the next bits I was going to talk about. So we've talked about making this gluten network, and we're now going to go onto the dough kneading and what's actually happening when we do knead our dough. So we could knead this by hand. Like I said, it's a wetter mixture. I tend to do it on using a stand mixer, and I'd leave it on there for probably 8 to 10 minutes to really get that dough coming together nice and stretchy. You can do the window pane test to make sure you've formed the gluten, and then we can mix in the fruit. What we're going to do here is we're going to go through to some of the sort of what's helping to form that wonderful structure of our gluten that we've got as we're putting it all together. So we're kneading it together. And I wanted to talk in particular about some of the bonding that's actually taking place that's tying all these proteins together, which is creating this gluten, this matrix, which is going to therefore suspend all these air bubbles and trap them all as the dough rises and give us that lovely spongy mixture. So I wanted to talk about the different bonds that are present. So the first one I was going to mention is a big part of that gluten network is actually about the disulfide bonds that are present, in particular between the cysteine residues. This can be intra-chain, inter-chain of those protein chains. That's to help to link them all together. So you've got the cysteine amino acid residues; they'll bond together. You'll form these disulfide bonds. There's a lot of those that are formed again to help keep that gluten network together. As we do the kneading, we're going to be doing a lot of shearing, so that actually they will split. They can move across, but then they can link to another cysteine elsewhere, and collectively all that tangling up coming together is helping to create that matrix. We've also got things like hydrogen bonding, lots of hydrogen bonding present. We could just move that pip, the little monitor at the bottom, so we can see that a little bit clearer. You'll see that we've got the hydrogen bonding. This one here is with serine and glutamine. Glutamine, there's a high proportion of glutamine residues in these proteins. They're really great for hydrogen bonding, and again, that's helping to form. We've got these hydrogen bonds mixed with these disulfide covalent bonds in there. So it's all these links together to helping to keep our to helping with this gluten network, this 3D network that we've got. There's other bonds in there as well. So there's other covalent bonds. You can get cross-links between tyrosine residues as well. There's hydrophobic bonds, other ionic bonds, again, all coming from the residues that we've got on our amino acids. And collectively, that's helping to form this 3D network, which is going to then suspend all these air bubbles as we then get that bread to rise.
Is it possible to over-knead your bread?
Yeah, you can overdo it as well, and you can actually, again, all that hard work you've gone into generating that lovely network, it can then you can do too much, because you want to be able to get nice air pockets, but not go too far and then the bee start to go too small again. A bit like when you do meringue. You want to get meringue, you want to generate that lovely nice foam, but then you can go too far and you can undo all that hard work, and then you can start to sort of mess around with that matrix that you're forming. So that's our kneading and our bond forming. We can now then go into one step further, and this is where now, talking about this strengthening the gluten network, I wanted to have a slide or two just talking about the different additives that people still use now on industrial scale, definitely were used many years ago, additives to bread to help strengthen the gluten network. And one of those ones is they used to add, you might have seen recipes, they might have added half vitamin C tablet or something like that. And you can still see vitamin C gets added to bread. You'll see it on the back of packets. You can see that actually has been an added ingredient.
And that's not just to make sure that the people eating the bread get more vitamin C?
And it's not just for that, but it's actually got a real reason why that is being added. And that is because the ascorbic acid, or vitamin C, can help to strengthen that gluten network. And that is because this now brings into play the ascorbate oxidase, which is the enzyme that I mentioned in one of the earlier slides. And what can happen, so the ascorbic acid can be oxidized to, as you see on the screen, the dehydroascorbic acid with the ascorbate oxidase. Then when this takes part, we've got this redox cycle. So I've got the redox cycle for ascorbate glutathione on the right-hand side. And it's this redox cycle, which is it's a fragment of this that I'm showing, that's coming into play for helping with this gluten network strengthening. So we've also got glutathione present naturally within the flour, along with these other enzymes. And what can happen is your ascorbic acid, your vitamin C that you've added into your mix, gets oxidized by ascorbate oxidase into your dehydroascorbic acid. That now acts as an oxidizing agent and can oxidize your glutathione that's naturally present in there into its dimer form. So the dimer form is shown there on the bottom left of the screen. And that dimer form, you've now tied up this glutathione in its dimer form, so that you can see it's got that free sulfhydryl group, which could interfere with the cysteine residues that we mentioned on the previous slide.
Right.
So if I now show this next part here, you'll see here that, again, if we can just move that bottom right-hand little monitor, you'll see here now, so by adding in your vitamin C, it is now tying up, it's being oxidized, it's then going to oxidize the glutathione, and then the dehydroascorbic acid itself be reduced back to vitamin C. But it's going to oxidize this glutathione into its dimer form, and therefore it prevents it from being tied up and interfering with the cysteine residues of our gluten network. So that's where that comes into play. That's why it was added, to prevent free glutathione from interfering.
That's so interesting. And is that something that you've tried out personally, or?
So And you can see that it does help. So if you're making something like, for example, if you're making like a lemon brioche, which is one of the ones we're going to show later on, it does puff up really well. You get a really lovely brioche out of it. And actually, if you go back and actually have a little look at it, you'll see that quite a lot of brioche breads do actually naturally usually use the zest of citrus in them. So they are obviously adding in that vitamin C in that just naturally by using a bit of fruit, and it must be helping with that gluten network. So that's what we've got there. I'm just going to wash my hands. Lovely. Perfect. So, right, so that's those. We're now going to go on to the next bit, going to be on to the proofing. So we come back to me now just no slides. So we've got our mix, we've got our sultanas, we've got our spices, we've got our zest now all into this bowl. I'm going to quickly just put it back under here, bring it all together, and then fortunately, in true Blue Peter style, I've got one that we've already made earlier, so we can have a little look at that. So let's just see how this one comes together very quickly. Is it back on? Just quickly mix that together. To see how all that goes. That's mixing really nicely now. Perfect. So I'll turn it off so it doesn't make a noise. But basically, you'd have mixed your dough. You'd have mixed your dough for 5 to 8 minutes on the mixer till it's nice and stretchy. Then you're going to add in your fruits because you don't want to put the fruit in too early on because it might start to be all broken up. You want to keep it. You want to try and keep it as it is. In fact, you can even just get that and you can just mix the fruit in by hand would be fine. I think just to save myself from getting covered in it, we'll just leave it in the mixer. And we'll go back to one that I've already prepped earlier, which is nicely risen here. So again, if you look down the top down angle, you can see that's the lovely risen dough. I've actually already divided this in two because I've already done a little bit of baking with other half of the dough. So you'll be able to see those in a moment's time. This is this lovely proven dough. And so what we can have a little look at now. So if you look at the top-down angle, you'll see again, that's the dough. What I'm going to do now is I'm now going to go back to a few slides and show what's actually going on in here as to why we've got this lovely, nice risen dough now. So if we go back to the slides, we've gone to the proofing. I'm going to zoom into now what have we actually got, what's actually happening if we look to the interior of this lovely risen dough. So if we were to zoom in now, this is now bringing into play all the bits that we've talked about so far. So I mentioned starch at the beginning. The starch granules, you can see those there, the different brown blobs. So what we've done is we've added the water, they've been hydrated, we've got a bit of warmth now naturally from all the fermentation that's going on, and they've begun to gelatinise now. That gelatinisation has now has caused those starch granules to swell, break up, and then now those polysaccharides, the long glucose polymers, these amylose, amylopectin, can now begin to become exposed. They're being released. You can see that top right. They're being released, and now they can be acted upon by the different hydrolyzers and chop them up, which is what we need for the fermentation. We've also got the gluten network, so that's zoomed in. So you can just see now, I keep showing this close up of this like spaghetti and meatballs, as I call it, but you can just see there, obviously, it's a massive, massive matrix that's going all the way throughout our dough. And we've also got the gas bubbles as well, and that's what they're shown on the side on the left. You see those big gas bubbles that are beginning to be formed, and they're going to be held in there by our network, our gluten network. So that's what we've got. If we zoom in, we're now going to go onto the components now of our starch and how they're all broken up. So this comes back into, so I've just talked about the gelatinized starch. Now what's happened there by gelatinisation, we've released these amylose, the amylopectin, these starch molecules, and then we can now get these to be chopped up. So I thought before we go into how they get chopped up by the enzymes, let's look in a little bit more detail now what they comprise of. So you can see here that the amylose have got these straight chains. These are these alpha 1,4 glycosidic bond linkages, these long linear polymers of glucose. Then for the amylopectin, we've still got those long polymers of the 1,4 glycosidic bonds, but we've also got these alpha 1,6 branchings that's happening. So every time we're seeing a branch, that's where the 1,6 is coming in, and you can see those on the diagrams there. You can see I've labelled them up. If you can just move the little monitor again for a moment, you'll just be able to see. You can see whereby you've got where they're joined together. We've got the carbon 1 and carbon 6 coming together. So that's why it's a 1,6 glycosidic bond. And that's where they're all linked together. And when what we're looking to do is that's the starch. That's got all of our glucose all tied up now. But we want to get that free, accessible glucose. That's a fermentable sugar that the yeast can consume to produce the carbon dioxide and the ethanol. So what's happening is the enzymes are all coming into play now, and that starch is being broken down into sugar. So that's what we've got on this slide here. So you can see here on the left-hand side, we've got our amylose, amylopectin yet again. Different enzymes are coming in. So we've got the amylases. They're going to come and start to chop it all up into smaller, shorter polysaccharides, these dextrins. Then they can come in again and keep chopping it up so they get even smaller. We've got the maltase can come in. They can chop up the maltose formed into the glucose. And at the bottom, we've got glucosidase, which can come in at any point there and chop off a terminal glucose. So lots of enzymes coming into play, all naturally present in our mixture, which I think is pretty amazing when you think about, again, we've just got flour, salt, water, and etc. And we're just bringing it up, and we've just got those on their own. But actually, there's so much going on in that mixture to help give us our end product. So now if we go one step further, actually have a little look where these enzymes are acting. This is now on this slide here, so you can see we've got our amylopectin there. And I'm just going to zoom in on a little section and blown that box up so you can just see where those enzymes are acting in each case. So you can see we've got the alpha glucosidase, which is coming at the end to take off a terminal glucose. Got our amylase coming in at a 1,4 glycosidic bond on the top there. We've got the beta amylase that comes in at the non-reducing end of the sugar, and so that's in the 4 position as it is on there, and that will take off a terminal maltose. So you can see we've taken off the N2, and then we've also got the limit dextrinase or isoamylase, which comes in and that cleaves at the 1,6 glycosidic bond, and that's going to chop it off there. So that's just in that small little section that's just zoomed in. You can just see where those enzymes are acting, but that can happen all over the place on those chains, and then it can happen all over the place at any different points, and you can see the different sections where it could come in at, and then that's going to help produce our glucose monomers at the end. So our little units of glucose, that's what we're going to show on this slide now. So again, we've got our polysaccharides top left, all those different enzymes coming into play, forming our glucose and our fructose, which is in the middle. And we've also got, on the bottom left there, you can see we've got other different types of saccharides that are present naturally. So we're going to have di, tri, tetrasaccharides all present by other enzymes, such as invertase. They can chop those up to produce the glucose and the fructose. And we've got other just free sugars naturally present in the yeast, in the mix as well of glucose and fructose. So there's all different ways in which we can get to these two sugars. So fructose, another fermentable sugar that we can isolate. That's coming mainly from the bottom left corner there. Obviously, we're getting just the glucose from our starch proteins, starch molecules there. And then the glucose and the fructose acted on, consumed by the yeast, producing our carbon dioxide and our ethanol, which is what we've got to give us this lovely, nice, voluminous risen dough, which is nice and puffy. So that's all of those little bits. Yes, what do you want to add?
No, just this seems like a great question to ask. Natalie's wondering, if your oven is otherwise occupied, where would be a good place to proof your dough?
So you can, if you haven't got your oven free, you can buy proving bags. I've got a proving bag at home that you can just, it's got little you just plug it in, and that's really great. I've got a really great airing cupboard at home as well. So I tend to prove my dough in there. Not everyone's going to have an airing cupboard, but it works really well for me. And at any warm spot, it'll be absolutely. Your kitchens are warm enough to prove dough. It just might take a little bit longer for different people. That's all it is.
Sometimes I'd put my dough on top of my tumble dryer while it was running.
It might work nice because if your oven is used for something else, maybe just put it near to the oven, and then you can and it will just help it rise there as well. So that works really well. So I think what we'll do now, we'll come back to just doing some actual baking demoing now. So we can move these out the way. And we'll just focus now on let's just do a little bit of shaping so we can see how the hot cross buns all come together. So like I said, we had that dough there. I've got another bit of dough here that I'm now going to shape. So let's move all these out the way so we're all ready to go. And it's going to be very much bake-off style now as we put this together. So yes, here we go. So I've got my half bit of dough left over here. We're going to scrape this out onto a floured surface. And then we're going to divvy this up. This mixture will make around about 1.2 kilos of dough. Pretty much bang on. So you should be able to divvy this out into 12 100-gram hot cross buns. That's what we should be able to do. So the first thing you want to just do is just knock it back, just so that because you're going to have some really big air bubbles in there, and if you leave those in, it'll be a bit like a focaccia where you've got these huge pockets in there, which it's great for focaccia, but I don't think we want a hot cross bun where we bite it open and we've got one humongous air pocket right in the middle.
It would be interesting.
So we're going to just knock this back a little bit, and then we're going to just divvy this out into 100-gram portions. You said you've not made hot cross buns before?
No, I haven't.
So after today, you can now have a go at doing them. Do you do much bread though?
I do bread.
What's your favourite sort of breads?
I really enjoy making challah, braided challah, mostly because it's very showy when you show up to a party with it. Everyone's very impressed, but it's actually quite easy to make. I'm also a very lazy baker, so I do it mostly in the bread machine.
No, that's fine. We've got a bread machine at home as well. And again, when you've got busy weeks, it's the easy thing to do, isn't it? My dad often takes control doing a lot of the bread mixer, doing that, because I'm usually baking, doing a lot of other bakes at the same time. So I reckon they're pretty even. We can probably just have if that works, we can see how accurate I can divvy it out into 100 grams. Where are we at? 90.5. Might just break a bit off those. So we're going to just break these off, get these into 100 grams. That's bang on. That was about there. Yeah, a little bit off that one. There we go. And then just going to come down to the shaping now. So we can probably go. Should we have the top down angle so we can see this a little bit easier? And so when it comes to shaping, get yourself a little bit of flour on the surface, and you're just going to basically just cup the bread. So you can first of all just sort of move it all into the middle. So it's got a nice sort of like domed top, and then you just want to put your hand over the top like a cage, and then you just sort of circular motion, just bring it all together, and just keep going and keep going and keep going, and eventually you'll end up with a really nice shaped ball of dough. And then for a hot cross bun, I like to just flatten it a little bit because it will puff up in the when you leave it to do its second rise. So if you just leave it as the ball, you'll end up with a really nice bulbous hot cross bun. Nothing wrong with that, but this one works fine. So that's those, and then you just do that for all of those. So maybe, do you want to do one?
Oh, I can try.
You can do one.
Can I ask you a question while I do one?
You can ask a question whilst we go away. Yeah, you can.
So I apologize because I can't check your name now that I'm doing this. But somebody was wondering how important it is to use fresh ingredients, especially when it comes to flour.
I mean, fresh is always best. I mean, some of the nutrient qualities will begin to go down as the older it gets. You can get those little like flour weevils can begin to come out if you have older flour as well. I think in the case of flour, it's not usually too bad because bread's one of those things that's been made for thousands and thousands of years.
Yes.
So yeah, I mean, I think that's relatively okay. I mean, we've got an enriched dough here, so we're also got in our eggs and milk and everything as well. So obviously, fresh eggs are always best as well. So that's really about it with that. Really.
It's not quite as beautiful as yours, but I've done my best.
That's perfect. Well, you do one more, and then we'll be about ready to go on to the next bit, which is sort of like the shaping. And then we're also going to bring into play. I'm going to show a few of the some other Easter breads that we can. That you can have as well, that are around from other countries in Europe, which are inspired by other Bake Off members. I've got some advice from Jürgen Klaus from the 2021 series of the Bake Off, and also from Giuseppe Delano, who was the winner of 2021 Bake Off. And I've got a German and a Italian Easter bread to show as well. So there's our buns. We can just put a bit of flour on that one.
Please fix my work.
No, they look fine. It's because you need to just. Nice floured surface, just so they can just stay nice. And we probably take those two off because they might burn on the top. There's those 6, and then you're just going to transfer those onto a sheet. And once they've proved, where have I put them? I put them over here, haven't I? Once they've risen and proved, you'll be left with these like this, and you can see now, if you go to the top-down angle, you'll see how much they've puffed up. So they're exactly the same as that one there. Oh, there you are. They're exactly the same as that one there. But you can see now these are really beautifully risen up. They're nice and puffy. And then they're ready now to have the X piped on. So I thought maybe before we go on to actually piping on the X's, maybe we just do a couple of slides now on this knocking back and shaping process and sort of what's going on there. So I think what's the next slide that I have set up? Actually, the next slide was actually to do the hot cross bun, the perpendicular crosses. So you can see on the right-hand side, that's the crosses that we've got on the top, and that is literally just using dead dough. So it's just flour and water mixed together and then just piped on the top. So there's nothing fancy to it. I know you thought when you arrived, it was icing, didn't you?
I embarrassed myself almost as soon as I met Josh this morning. I always thought it was icing. I blame my roots, blame my Canadianism, but I really thought it was icing on top.
So we can we'll just make some. We'll just make some now. So all you want for that, so we can come back onto the camera now. All we've got to do for making the cross on the top is literally just equal quantities of flour and water. Bread flour works, I guess I'm going to have a spoon. Bread flour works absolutely fine for this. It might be a little bit tougher to rip apart, but it's absolutely fine. So if I just put a bit of flour in a bowl, like this. And then I've got some water as well.
This might be the perfect opportunity to ask you another question that's come in, which is essentially, what is the difference between bread flour, all-purpose, pastry, why? That might be a big question, but for making things like hot cross buns and bread, does it matter what you use?
It really does, yeah, and that was one of those ones I was going to come to that question, so I'm so glad I'm so glad someone asked me, because I probably would have forgotten. So it's really all about the protein percentage that we've got in the flour. So we talked about the gluten network. To form that gluten network, we've got those gluten proteins. They're all meshing together, so we need those to help give that lovely gluten framework to have a really nice stretchy bread, which is what we want. So the flour percentage, the flour protein percentage for bread flour is around about 12 to 14%. And as we go down to other uses, we tend to have lower amounts. So your all-purpose flour is going to be somewhere around about 9 to 12% protein. And then if you want something like pastry flour, it's usually somewhere around about maybe like 8 to 9%, a bit lower again. Again, because if you want a nice crumbly shortcake base for your pastry tartlet, you don't want it to be all tough and bread-like. You want it to be nice and crumbly and just melt in the mouth.
Interesting.
And then sometimes you can get cake flour as well, and cake flour's got really low protein percentage.
Okay.
So we're down to around about 7 or 8%. And that's going to, again, you want a lovely, nice, light, fluffy cake. It's not glutinous at all. It's just lovely and nice and crumbly, and just has a beautiful cake-like texture. So yeah, it's the flour percentage, which is the flour protein percentage, which is the main difference between those two.
Interesting. Okay.
But you can definitely get away making breads with normal all-purpose flour.
Guilty.
It won't work quite as well. I think for things like a soda bread, which actually is one I'm going to show in a minute, that actually works better, because for a soda bread you're not actually mixing it together. Because you've not got the yeast in there, you're just using a raising agent. So you just want it to just come together. So it's a bit crumbly, but it still has the look of a bread, and you can make it in a nice quick time. So so I'll just put a little bit more water in here to make this so that it's just pipeable. So it doesn't look the prettiest of things, but it's right. There we go. A little bit overboard there, so a little bit of flour back in. This is like bucket chemistry now.
Exactly. Just like chemistry, baking is all about troubleshooting.
Yep. So we'll bring them off together. Right. That's just nice. That's nice and gloopy now. So we should be able to hopefully pipe that out. Might just need one little fraction more of that in there. Right. That's perfect. So I think I've got myself a piping bag here. We can just pop this into here. And like I said, so what we've got here is we've got this dead dough, which we're going to pipe on top. This will stay pale. It's got there's no like fats and everything else in there, and sugar in there to really colour up when it goes into the oven to caramelise. And so that stays pale, but obviously our enriched dough, which has got egg in there, it's got milk, it's got butter in there, that will colour up, which is why we get the definition of the cross versus the really dark coloured bread.
Interesting.
So that's that. So if I just pop the end off. So if we go back to these ones here, maybe I'll just move those out of the way so they're into shot nicely. You can now, probably on the top down, that's perfect, that'll work. And then now I've put it in a piping bag, and I've chopped the end off. You can use a plastic bag, little like one you put like your sandwich in, works absolutely fine. You can use a bit of baking parchment, and you can just roll it up and cut the end off. So if you haven't got a piping bag, you can still make a equivalent one. And you're literally just going to pipe on over the top. And I always think for a hot cross bun, you want to have these. So I've only got 4 on the tray here, but you want to put all 12 on one tray, leave around about 1 centimetre to 1 inch gap, let them sort of fill that space, so that when they bake, they just touch, because you want to be able to tear it apart. So that's what you've got. So and then you're literally just piping your X right over the top, like that. Am I going to have enough? Yeah, I think I should have just enough to do that as well. So again, over the top. There we go. That's it. So there's our crosses. We can now put those into the oven, and at the same time, I shall now bring out. Like this in there. Yep, perfect. At the same time, I brought out. I've just done a couple here that I did earlier. So if you look top down again, you can just see here's just a couple. Obviously, we've got the big set of 12 there as well. These ones have literally just come out of the oven now. And so now you would just do a little glaze. So like I said, for the glaze, you can either use your cinnamon tea that you've got left over. You could reduce that down, use that on the top. I like to use apricot jam. So I've just got some apricot jam here. The apricot jam, I've sieved it, and then I've just added just a teaspoon of water just to loosen it a little bit, and you can just brush that over the top of your. Move that into the centre a bit more. Just brush that over the top of your hot cross bun, like that, and it just gives you that wonderful sheen. And again, you do this on a lot of like fruit cakes. So between where you put your marzipan and your icing on top, you'll have a apricot glaze. It's a really great substance to use to help stick things together. So people use them on chocolate cakes as well. They'll use it again just to help before you put your fondant layer on.
And if you're not an apricot fan, what could you use instead?
Like I said, so you could use the cinnamon tea in this case, would work really well. You can make a simple sugar glaze, would be fine. So just 1-to-1 water and sugar. Again, just cook it down a little bit. So make sure the sugar is dissolved, and you can brush it over the top. That'll work absolutely fine. You can use all sorts of syrups as well. So I often use. So you can get like the cordials. So like you can get like your elderflower cordials. Those again, they're very sugary. So those just reduce down, or you can almost use them neat as a glaze. They work really well as well. Maybe put a little bit more sugar in, just so it's a little bit more syrupy. But that works really well. And then that's really it. That's your hot cross buns. So they've got a lovely, nice sheen to them. And then that brings us sort of quite nicely now into some of the other Easter breads that I wanted to talk about. So we've got the hot cross buns, and I wanted to talk about a German one and an Italian bread that you can also make as well. And this, like I said, I've got inspiration from Bake Off alumni to do this. So I shall move these ones out of the way for the moment. And if we go back onto the slides, I've actually got a little bit of a photo just to give you an intro. So the first one I'm going to show you is called Osterzopf, and it's a German Easter bread. This is a recipe that's actually come from Jürgen Kraus, who was a semi-finalist of the Bake Off. It's come from his book called German Baking, and we actually had him here at this site at the Science Kitchen at the university a couple of weeks ago for Pie Day. You can see the photo there, top right. We made a German cider apple pie with pie symbol on top, which was wonderful. And this bread, which I shall now bring into shot. So we can now see that. Like that. There we go. You can see that. Not pushing it. That's perfect. Right, there's that. So this is the oh, look at that. There's a lovely photo there. So you can see that side on. So this bread has actually used baking powder as opposed to yeast. So if we go back onto the slide, you can see the recipe list. So you can see it's very much like a normal enriched dough. You've got your eggs and some milk in there, but it's also got in, like I said, baking powder as opposed to using yeast. Now I naturally would usually use a soda bread, but classically use bicarbonate of soda because it usually uses either buttermilk or yogurt as the acidic element to help with your basic sodium bicarbonate along with your acidic yogurt or buttermilk, and you'll get that sort of that reaction to occur where you're going to get your carbon dioxide and water produced. So I'm not going to change Young's recipe, but I think you would have got away with absolutely fine with the baking powder, with the bicarbonate of soda on its own, because you've got your yogurt in there. We've actually got lemon zest as well, so got quite a lot of acidic elements. This has got raisins in, it's got eggs, and again nice and enriched dough. It's then just platted, and you've got some flaked almonds that have been put over the top and then baked. So that all looks wonderful. And then the other one that I was going to show, and this one is an Italian Easter bread. And if you look top down, you'll be able to see that one now as well. Move these out of the way. There we go. And this is the Italian one. If we move on to what? There we go. I'll hold those up to the camera so you can see. Like so. This is an Italian Easter bread. Again, this is an enriched brioche dough. And this really brings into play now when we talked about using lemon in a brioche. does help. It's got the vitamin C in it, helping with that gluten strengthening. And we've got a lovely, nice, puffy brioche bread here. I haven't tried these ones yet, so I'm really looking forward to digging into these. The eggs, they've just been painted. If you go back to the slide, actually, I think I've got a photo on there. I'll move on to the next slide. The eggs for these ones, they've been painted, then left to dry. You just want to wash off some of the excess food colouring, otherwise it will colour your bread. And then you can just sit them in raw eggs sat into the bread before they bake, and then you get this wonderful finish. And this one, again, this is inspired by Giuseppe, who is the winner of Bake Off in 2021. The recipe is on the left-hand side. Again, we'll make all the recipes available if anybody wants to have a go. It follows exactly the same sort of procedure as for the hot cross bun. It's an enriched dough, flour, as you can see, they've got flour, yeast, salt, sugar again, some melted butter and some milk, all exactly the same. We've got a few more, 3 eggs in this mixture, so it's a bit more towards a challah or a brioche bread like you mentioned. And we've got a bit of vanilla bean paste and some lemon in there as well. And these then just decorated with a few sugar nibs on the top. So collectively we've got 3 wonderful Easter breads from across Europe. And hopefully everyone can have a go at making those at home. Now, the last thing I wanted to talk about on a few more slides, whenever it comes to baking, everybody talks about Maillard reaction. It's always like the classic one we go to. And I feel like this is actually a really great example to talk about that, because we have got enriched doughs and we have got a lot of coloration on the outside. So I've got a couple of slides to finish just to go through that Maillard process. So if we just go on to the slides again, we're going to talk about the Maillard reactions. Again, they always get mentioned. We know that it's sugar, protein, and heat coming together, and it's giving us the colour, the flavour, the caramelisation that we're going to have on our bread. So this is what we're seeing on all baked goods, but I think it's particularly prevalent when we come to baking breads and cakes, is we've got this lovely coloration on the outside. And what we've got happening here, as you can see on the slides, we have got our sugar is coming into play again, our glucose. This is now showed in this open chair sort of linear form. You can see it there with the aldehyde on the far right, aldehyde unit. That will then react with an amino group of all of our amino acids from all of our proteins present. They'll come together in a classic condensation reaction. They'll form these N-substituted glycosylamine, or an imine, as is shown now on the right-hand side. That's an unstable formation. It will then rearrange itself by the Amadori rearrangement shown now on step 2. And if we just remove the little camera on the bottom right, you'll see the product. This is that N-substituted glycosylamine going via a 1,2-N-amino to the Amadori compound, which is this ketosamine. And then this now can go on to do a multitude of different other reactions. So if we go on to the next slide now, we can go on to form, so all sorts of different, just an example here, some in alkaline and acidic conditions, because we can get different products being formed. In fact, the Maillard reaction is sped up greatly in alkaline conditions. So often, if people are making like pretzels or bagels, you will sit your bread in a vat of boiling water, and it will have probably a bit of malt extract in, and it'll have bicarbonate of soda, or in the past they'd have used lye, potassium hydroxide. It's basic in there. It's going to coat that on the outside, so it's all alkaline, and that actually speeds up that Maillard reaction. So when it bakes, your pretzels, your bagels get really dark coloration on the outside. That's sped up that process. So that's in the alkaline conditions, and we've got acidic conditions. We can get things such as hydroxymethylfurfural is more prevalent. And then these can go on to make a variety of other flavour compounds. So there's a variety shown here. If we just remove the camera at the bottom right, you can just see those examples there. So all sorts of volatile, small, aromatic flavour compounds. We've got pyrazines, pyrols, alkyl pyridines, etc., furans and oxazoles on the right. And you can see some of the sort of flavour notes that they're adding. And they're all sort of these toasted, nutty, malted, caramel sort of flavours. But again, that is what we think about the outside of all of our bakes. We always refer to them as that sort of like caramelisation, those lovely toasted sort of flavours. And then also what can be formed, the melanoidins can be formed as well from these ketosamines, and these are these long brown coloured pigments, or these polymers, which are going to give us the brown coloration of our the Maillard reaction is giving. It's giving these caramelised colours, and so we've got the brown pigments alongside all these flavour compounds, which is really helping to just elevate that bake. It gives you that attractiveness. We know it packs in lots of flavour. If you listen to Paul Hollywood do his judging, his first thing when it comes to bread, he will always say the darker the better on the bread. He wants that dark finish because it just adds another level of flavour to your bake when you can give your bread that coloration.
Well, it's absolutely perfect you've covered this because we're starting to run out of time, or actually we're technically over time, but somebody was asking about that. So it's perfect that you've covered that. One thing, if I could ask you another question just for the audience, Natalie was asking, basically, how has your time on Bake Off changed the way you bake, or has it? Or do you still bake the same way that you did before? Has it made you a better baker?
It's definitely made me a better baker. I mentioned at the start about some of the skills that I'd probably taken as a chemist that really helped me on the Bake Off. But again, there's so many things that I've taken from Bake Off that again have come back and really helped me in the lab as well, but also with to take the baking to a new level as well. And so yeah, baking's really made me. The Bake Off's made me think about baking in a new light. I can work incredibly quickly now, doing multiple things at once. I actually, although I've been always somebody that would stick to a recipe, because I can do them so quickly now, I've had so much experience doing them, I don't need to follow recipes all the time now. I just know I can do it a bit more by hand, which is really, just by feel, which is really weird because before I was always very strict, like I do not change, I weigh it out very accurately. But I know now if something doesn't quite look right, so you know how to recover it. If your dough's a bit too loose, you'll just know to add a bit more and not just go with it. So yeah, I've definitely been able to recover with that. And it has really helped in that regard. So yeah, mentioned we're coming towards the end. I think I've just got, what time are we at? We're just over 1. Are we ready to sort of begin to wrap up?
Start to wrap up.
Start to wrap up. So yeah, so I'm hoping everyone found this really interesting. And just I gave that little more of an insight into some of these bakes, that, especially hot cross buns, that you're just naturally going to have every year anyway. And and hopefully for everybody watching, whether you are just an amateur baker, whether you're coming in as you're a student, if you're working in industry, in chemistry, if you're working as an academic, hopefully there's a bit in there for everybody, and they're going to have a go. The recipe will be available, and you're going to have a go at it yourself and maybe see it in a new light. So yeah, that really brings me to the end. I think we've got. I've got a final slide at the end, just to thank you all. Thank you all for listening. And if anybody's got any questions, please do get in touch. I've got a website, available on all of the social media channels. So yeah, please do get in touch and ask me any questions that you want regarding any of the bakes and anything else chemistry or baking related. So thank you very much.
Thank you so much for having us and for sharing your expertise with us. I think we've snuck in quite a lot of audience questions kind of throughout, so I'll just end on one kind of classic one that I saw come in earlier, of how important is it to use unsalted butter when the recipe actually calls for unsalted butter, particularly because you mentioned that the salt can kill yeast.
Yeah, so I think classically we tend to default, most recipes will use unsalted, and then you can sort of, again, you can add in the salt as and when needed for the recipe. For things like cakes and things, you don't need salted butter. You wouldn't really add salt to your mixture. So I would always go for the unsalted. But sometimes I do blends of the two. Things like buttercreams and things like Swiss brown buttercream, I often do a little bit of a blend in there as well, just helps to give it an overall nice rounded flavour. But yeah, I think at least with the unsalted, you can add the salt as needed to get it to the right level. Whereas if it's already in there, you can't take it out.
That makes total sense.
Yes.
Okay, thank you so much. I will hand back to Ben back at the office, and we hope that you'll join us for the next Chemistry World webinar.
Thank you so much, Ada, and thank you, Josh. We also really should thank your team in the chemistry kitchen there at Leicester University. We've had lots of help from Mike O'Brien and Scott Skidmore, who have been making sure everything runs smoothly behind the scenes in Leicester. Chris Pink has been making sure things run smoothly behind the scenes here at Chemistry World Towers. And it would be remiss of me not to thank Natalie Starkey, who did all of the legwork to get this set up before she left Chemistry World for her new adventures. And she's actually been with us today asking some really insightful questions as well. If you've enjoyed this, you will also enjoy our previous webinar with Josh that we ran last year. That is available to watch right now. And if you would like some more inspiring chemistry conversation, we also have an upcoming webinar that I think you will all enjoy. Let me just try and make sure that's in the chat as well. We're having an in-depth conversation with Melanie Sanford. Now, most of you, if you're a chemist, will probably have heard of her. She was a cover artist for Chemistry World recently, and we're going to have a really good chat with her. Also one that Natalie has helped to organise. So please do join us for that. A final thank you to everybody for today, especially to Ada, who's travelled all the way to Leicester, and Josh and his team for making that wonderful demonstration happen. Thank you to the audience for all of your excellent questions. We didn't quite get time to get through all of them. There were so many, but I think we covered a lot of ground in just over an hour with Josh. Thank you ever so much, everybody. We'll see you again for another Chemistry World webinar.